And this is the distance along the curve. From one endpoint to the next. Okay, so when you're dealing with an arc length, now it's no longer talking about just the measure of the arcs. Now it's actually talking about that one-dimensional length. Okay, so it'll be measured in inches, centimeters, whatever units that you're describing. And it's still going to be tied to arc measures, but if I wanted to find the arc length here, so again I'll just refer to these points as A, B, and C. Okay, arc length is designated with a lowercase s. Okay, and so when you're finding your arc length, it's a portion of the circumference. So let's talk about circumference again. The circumference of a circle is given by what formula? Josh?
2 pi r.
So one of them is 2 pi r, and we could also use 2r is equivalent to d. So these are your two equations for circumference. So when you're dealing with the arc length, which is this lowercase s, it's some portion of a circle's circumference. Well, let's figure out what portion that is. If we know the arc measure, m, of AC, we can find its arc length by taking m over, and what would be a complete circle back onto itself? What rotation or measure? An arc measure of 360. Okay, so if you want the fraction of a circle's circumference that's represented by an arc length, you'll take m over 360 times that circle's circumference. So here is your equation for arc length. Now, you're going to have one of two forms for this. It either depends on whether you're given the radius or the diameter. So arc length is either going to be m over 360 times 2 pi r, or it's going to be m over 360 times d pi. It doesn't really matter which one you use, because the calculations are pretty basic that distinguish these from each other. And so if you're told what the radius is and you want to use this formula, you can. You can just double the radius. If you're told what the diameter is and you want to use this equation, you just cut it in half and plug that in for r. Okay. So here's the type of question that you might see like in a real basic sense. We'll do some more advanced examples tomorrow. But let's say I gave you, in circle P, length of QR in this problem. And what you're told is that this angle has a measure of 30 degrees, and PQ, the radius of this circle, is 8. Can you find what the arc length QR is equal to? Okay, so what is our m value? If our angle T is 30, that means the QR has an arc measure of double that, 60. So we get 60 over 360 times, and because we're given the radius, let's use 2 pi r. The radius is 8. And we can now calculate through. The factors of 10 cancel. 6 goes into 36 6 times. 2 goes into 6, 3. And when you multiply across, you get 8 pi over 3. And so just to, since this comes up here, if I wanted the exact or the approximate answer, the pi button on your calculators is located right here above this caret symbol. So if you wanted to type in 8 second function caret to get pi divided by 3, and since I'm in auto mode, if I want it in decimal form, I can either hit the green diamond button and highlight this diamond, or I can put a decimal in my display, hit enter, and I get my answer, 8.3775, etc., and round it to whatever it might ask you to round it to. All right. Let's take a look at some of the angles and intercepted arcs that we're dealing with here. FHE. What kind of an angle is FHE? And this is circle H, by the way. FHE is a central angle. So here the vertex is the center. And what is the measure, or what's the relationship between the measure of the angle FHE and its intercepted arc? They're the same. So here's our angle. So the interior is everything in between here. So the arc measure is identical. Measure of the angle is measure equal to the measure of the arc. Okay, so we've talked about this already. We've also talked about if we're looking at angle FCE. So if we looked at measure of angle FCE, what kind of angle are we dealing with FCE? Here the vertex is where? It's inscribed, so it's on the circle. Okay, so if we look at this, angle FCE has an interior, again, if we were to identify. Here's FCE, so all of this is our interior, so the portion that's contained in the interior of that angle is still just FE, and the relationship is we're dealing with 1/2 the measure of that intercepted arc. Okay? So this is review so far of what I talked about on the last, the slide before last. Okay, there's a couple more relationships to keep in mind. The next one has to do when the vertex is in the circle's interior. Okay, let's see what's going to happen when your vertex is in the interior. Well, H is one example of that, but we already have a rule for it. So let's look at G. So let's find the angle FGE. Okay, when you look at FGE and want to identify its interior. Okay, so here's FGE. And so the interior is still here. So what arc is in that interior? Once again, FE. Okay, but there's another angle that is related to FGE that you need to take into consideration, and that's the vertical angle to FGE. What is the vertical angle to FGE? AGC. Okay, you have to consider that interior as well when you're looking at intercepted arcs. So when dealing with a measure of angle FGE, where the vertex is in the circle's interior, you have to consider both the original angle and its vertical angle, and you have to look at the intercepted arcs between each of them. Okay? And the angle measure itself is going to be the average of those intercepted arcs. So you're going to take arc FE, you're going to add it to the arc that's intercepted by the vertical angle, AC, and then divide by 2 in order to average them. And that's going to be the measure of angle FGE. Once again, I'll go through some examples of these tomorrow. I just want to introduce the equations. So when we do the examples, you will have at least seen this before. Okay, the final example is an angle where the vertex is in the circle's exterior. Okay, and so that would be an example like J. So I'm just going to call it angle J since there's no confusion of which angle I'm talking about. And when you look at angle J, you have to consider, here's its interior. So once again, you have, I'm going to darken it a little bit. Here's that angle. So there's more than just one arc in its interior. And this angle intercepts 2 arcs. What are the 2 arcs that are intercepted by this? Arc FE still, and arc CD. So when you look at those 2 arcs, in order to find when the angle's vertex is outside the circle, your angle measure is 1/2 the difference of the arcs. So FE again, but this time you're going to subtract that, or subtract the other arc measure CD from that, and that's going to give you your total angle measure. Okay, so this is where we'll pick up tomorrow. I just